say the area of the stopper here is 5 centimeters square, and you apply a force with a value of 10 Newton. So you create a pressure equal from force over area as 2 Newton per centimeter square. This pressure is transmitted by the liquid to every side of the container. So, at the base of the container, this pressure is also transmitted. As pressure is equal to force over area, then I can say that force is equal to pressure times area. So this transmitted pressure, which is equal to 2 Newton per centimeter square, times the area of the base, which is equal to 500 centimeters square. So you see that a 1000 Newton extra force comes from the transmitted pressure. So I apply a little force but create a bigger one just by the transmission of pressure by the liquid. The application of Pascal's principle in hydraulic press. This is an hydraulic press. These are the pistons, the small piston with an area of A1. This is the big piston with an area of A2. This F1 is the applied force, the input force. So when you apply the force F1, you create a pressure P1, which is equal to F1 over A1. This P1 pressure is transmitted by the fluid and exerted to the big piston. So this creates a force. We say that force is equal to pressure times A. So the created force is equal to P1 times A2. P1 is equal to A1 times F1 time over A1 times A2. So here you see that I have the ratio F1 over A1 is equal to F2 over A2. So if you take the small piston, A1 is smaller than A2. If you apply the force to the small piston, then you create a big force at the big piston. We have an example. If the lift cylinder is 25 centimeter in diameter, this is the lift cylinder. It has a diameter of 25 centimeter. And the small cylinder is 1.25 centimeter. This one, 1.25 centimeter in diameter was the force to be applied to the small cylinder in order to lift a 6,000 Newton car. Now, we have the ratio F1 over A1 should be equal to F2 over A2 in order to get balance. Now we have to find the areas. We have the diameters 1.25 and 25. If I say this has a radius of r, then this is 20 times of r. So as area is proportional to the square of the radius, if this has an area of A, then this should has the area proportional to the square of the 20r, so 400A. So F over A should be equal to 6,000 Newton over 400A. A cancel each other, zeros go, so the applied force should be equal to 15 Newton. Now here we have the B part. How many centimeters do you have to move the small piston to lift the car 10 centimeters? When you lift the car 10 centimeters, you lift the car 10 centimeters, you have to push the piston. So this amount of water will fill this amount of water. So they should have the same volume. As volume, let's do the B part here. Volume is equal to the base area times H. This has a base area of A times the unknown amount of motion is equal to, this has a base area of 400A times the amount of motion 10 centimeters. So the A goes, I should move the small piston 4000 centimeters, which is equal to 40 meters. The use of Pascal in daily life in hydraulic brakes. You apply a force on brake fluid by brake pedal mechanism and create a pressure. This pressure is transmitted by the fluid. So you see that this have a larger area. So F1 over A1 is equal to F2 over A2. This is your applied force to the small piston. So this is your big area, create a bigger force. With an air mattress, you can ignore the rocks and sticks that are on the ground beneath you. The air mattress pressure will be distributed equally over your body. Thanks, Pascal. When an extra pressure is exerted here, it will be transmitted equally to all parts of the bed, so you are not going to be disturbed. In this example, the given objects x and y are in equilibrium. Find the ratio of their weights. Now, in the first figure, these points that are at the same level, touching the same liquid, should be equal. So let's say A, B. The pressure at A is equal to the pressure at B. The pressure at A is equal to the pressure exerted by the D liquid with a depth of 2H. So D times 2H times G is equal to the pressure at B is applied by the solid object X. So force over area, which is equal to 2S. Now let's come to the second figure. Again, I set 2 points at the same level, touching the same liquid. Let's say C and D. The pressure at C should be equal to the pressure at D. The pressure C is exerted by the D liquid with a depth of H. D times H times G is equal to the pressure at D is exerted by the object Y. So the weight of the object Y over the base area S. So when you take the ratio, the HG and S cancel each other. So I have the ratio X over Y equal to 4. In the last example, the given objects X and Y are in equilibrium as in the figure 1 and 2. Find the ratio of their weights. Again, I set 2 points at the same level, touching the same liquid. Let's say they have the density of D. So A, B, the pressure at A should be equal to the pressure at B. The pressure at A is exerted by a D density liquid with a depth of H. So dH times G should be equal to the pressure at B is exerted by the K object, K over 2S. In the second figure, again set 2 points at the same level, C and D. They should be equal. At the C, the D, that's the object with a depth of H, exerted dHg pressure. At D, the pressure at D is exerted by the L object, which is equal to L over base area 3S. So when we take the ratio, we find the ratio of the weight of the objects K and L as 2/3.